So we'll look at integration by substitution. This is a setup where instead of dealing with a variable, let's say you have a function f of x here. Instead of dealing with the variable x, for some reasons, you convert your function to dealing with maybe a neutral variable u. Okay. So you're trying to change things to where you're able to use easy methods that can help you get a solution. So I'll explain well using examples. Evaluate.
So is this the first page or maybe you've already done?
The first page.
There's another.
So we're tapping from question 6 of the tutorial sheet. Evaluate the integral of 4 of x multiplied by 7 plus 6x squared power 9 dx. So here's a question that looks like we can use extended power rule. It looks like we can use extended power rule here. But if you can do that, it means you have to expand power 9. You have to multiply 9 times. Even if you've done binomial, that's not an easy thing to do. Okay, so how do we avoid going that way? So you say, okay, why can't we change the variable from x maybe to another variable by naming a certain part? So we'll go in the brackets here and let the whole thing in there be u. 7 plus 6x squared. We are doing that because we have checked the power of x inside the brackets is 2 and the power of x outside the brackets is 1. So if the difference in powers is 1, then we can use substitution rule. How do I know I can use substitution rule? If the power of x in the brackets is higher by 1 to the power of x outside the brackets. And then now we differentiate u with respect to x. What do we get? We get the derivative of 7 is 0. The derivative of 6x squared is 12x. This means that we are getting du is equal to 12x multiplied by dx if we cross multiply there. Now we need to come back here and change things. So we're changing the variable. We have 12x, and then we have called this u. So we have u to the power 9. And then this dx, we want to write it in terms of u. So we solve for dx here by dividing 12x by dividing 12x. So this will cancel. And so we're going to have dx is equal to du over 12x. So here we have du divided by 12x. So we are almost managing to eliminate all the x variables there and just remaining with u. As we can see, this 12x and this 12x can cancel. We therefore remain with the integral of u power 9 du. Okay. So now we can integrate easily. So say to integrate u power 9, we just add the 1, becomes u 10, and then divided by 10 plus a constant c. But we can't submit our answer in the u form. You put back the x. So you said u is 7 plus 6x squared. So to the power 10 divided by 10 plus C. This is what we have. So for you to know that I'm now supposed to use substitution rule, check the powers of x in the brackets and the power of x outside the brackets. If the difference is 1, then you're using substitution method. Let's pick another one. This was A, I think. Yeah, so I'm now going to B. B is the integral of 4x power 3 minus 12x, and then divide by, divide by x4 minus 6x squared dx, like that. So if that is the situation, then again we check the denominator and the numerator, which one has a higher power. So you find that the denominator has a power 4, which is bigger by 1 to the power 3, which is in the numerator. So you'll say, okay, then my u is going to be the denominator, x4 minus 6x squared. Then you differentiate. We're getting 4x3 minus 12x. Because we're doing the x here. So if you cross multiply, we have du is 4x3 minus 12x multiplied by dx. Sometimes it's not a must that you must always solve for dx. If you look at how this question is, you could write it as the integral of 4x3 minus 12x multiplied by dx over x4 minus 6x squared. So what does that mean? You can easily substitute. The whole numerator here is what we have equated to du here. So we are dealing with the integral of du over, the whole denominator is our u, over u. So every time I have du over u, every time I have du over u, it means that the integral is ln of u plus c. Why are we saying ln? Because to differentiate ln, if you're differentiating ln of gx, if you can remember, you're going to get the derivative of g and then divide by the g itself. So when we have du, du is the derivative of u divided by u. So meaning initially, before it was differentiated, it was ln u. So we have to take it back to ln and then plus c. But this is u. Our answer must be in x form. So we get x. Okay, so x are 4 minus 6x squared, like that, plus c. But I must emphasize that here it always have to be in absolute because we want it to be positive. That's why we put the absolute values. Because ln does not take anything negative, it only takes positive things.
Sir, repeat, sir.
So you check every time you have a fraction, because don't have quotient true in this integration. You look at the powers, which one has a higher power? In most cases, the denominator will have a higher power as compared to the numerator. But if the difference is 1, then you know that, oh, I have to use substitution method here. So how do I use substitution method? I let the denominator be u, and then I should be able to differentiate u. So how do I differentiate u? So okay, because my u is x4 minus 6x squared, then I use power rule here. I'll have 4x, 4 minus 1, you get 3. minus 6 times 2, 12, x, 2 minus 1, we get 1. So this is a derivative of u. Okay, since we are changing from x to u, it means even the dx must be replaced. Since we are changing from from x to u, even the dx must be replaced. We don't want it there. We want to have the u form. So we're looking for du here. But how is du and dx? How are they related? So you come here to the equation where they are all there. This is du over dx is equal to this thing here. So from here, you solve for dx. So you cross multiply. You're going to have du is equal to 4x to the power 3 minus 12x in brackets multiplied by dx. But if I go back to my integral, I'm able to rewrite it in this form over this. But this is what we have here. On the right, on the left, we have du. It means these two sides are equal. If these two sides are equal, then where there is this whole thing, we can also use du. So we have placed du there. And then we divide everything by this has been called du. Now, if I have du over u, if I have a derivative over the function whose derivative I have in the numerator, to integrate this, you introduce ln of the function whose derivative is in the numerator. So you pick the function u and put it in ln plus the constant c. So the question was, why are we introducing ln? Because when you differentiate ln of a function, you differentiate the function and divide by the same function. Yeah, this is the first slide. So that it makes sense now that, oh, okay. So this what we have is ln u plus c. But what is u? We introduced u here as x4 minus 6x squared. So we substitute plus c. But we remember that this inside of ln can never be negative. So we restrict it. We want it to be positive. Like that. That's always our target.
Sir,
Hello.
you mentioned about comparing, like the first thing you do, you compare the one with the highest power. Then you mentioned something about, like, if the difference is 1, that's when you do this. I don't know if I heard you properly, but that's what I heard. So when the difference is not 1, what do you do?
So there will be another method that you can use. If the difference is not 1, you may not have to use substitution method. So maybe we'll have such questions, we'll see what to do there.
Sir, every time when you're given a fraction, does it mean that we're supposed to use this formula for ln, or we can still use the same method that we've used on question A, on B?
On question A and B. You're comparing this to this method that we used here.
Mm-hmm. Is this not the substitution method that you used? It's the same, right?
Yeah, it is.
So I was asking, yes, so is it okay if I was to use the same method that you used, like completing everything, even on B, without including the natural?
It's not possible.
It's not possible.
No, because if we try to go that way, then we would want to raise this. We would want to write it as u to the power negative half. I mean -1
Yes.
du. Now remember, to integrate there, we must add the 1, is it?
Yes.
And divide by what we get. But this is 0.
Okay. All right.
Every time we divide by 0, you have undefined things.
Okay. Thank you.
Okay. Okay, another one. I'll pick I'll pick L. The integral of 9e to the power x over e to the power x plus 4 plus ln 2x to the power 2 over x. Everything under dx. So how do you do that integral? So you look at the first piece there, because I know we can separate this. Say this is the integral of 9e to the power x over ax plus 4 dx plus the integral of ln 2x to the power 2 over x dx. We can have it in that form. But I'm able to integrate it. So you check. Remember, for exponentials, it's not about subtracting from the power or adding to a power. Yesterday we said that the derivative of e to the power x is going to be e to the power x. I don't know if I mentioned it here. I should be. Yeah, I think I did. So we get the integral of e to the power x is e to the power x itself. So it means that if we come here, we'll let u be equal to e to the power x plus 4, and then differentiate u. When we differentiate u, we get ex, then multiplied by dx. So this is telling us that, well, we can change actually from here. Now what we have is, I can write 9 outside, and then where I have ex multiplied by dx, I can simply place du, and then divide this ex plus 4 is what I have here as u. So I put u here, plus. Where do we go? We now come this side. We know that if we let u to be ln 2x and differentiate this, its derivative du is going to be 2 over x dx. That's how we differentiate ln. Remember, to differentiate ln, you differentiate what is inside ln and then divide by the whole thing. So what we have, we'll differentiate and then divide by 2x. Yeah, so we differentiate 2x, we get 2, and then divide by the whole 2x, which is going to give us du is equal to 1 over x dx. It means we can write this down here as the integral. Where there's ln 2x, we are putting u. So we have u squared. And then 1 over x is what we have here as du. So we have du like that. Because remember, for us to have x down there, we can put a 1 here if we want to see that we have 1 over x. Okay. So this is what we have to integrate now. So what are we doing? We're saying every time I have a du over u, I bring in ln u plus u squared. We simply do u to the power 3 over 3, then plus the constant c. But now look, these u's, we're naming them different. So I can put u1 here. What I said du1 here. I'm just trying to differentiate them, but it doesn't matter. If you understand what your u is there, there's no confusion. So when we come here, we're going to have 9 ln. So which u is this? So this one I've named it u1. This u is here. P x plus 4 plus u to the power 3. Now the u here is ln 2x. So we put ln 2x to the power 3 this time around over 3 plus c. But you may not need to worry about the lines here because the thing that is inside will always be positive. For any value of x that you put here, it remains positive. So I can be free now to use even this type of brackets. Like that.
So you said that for every value of x we put where?
For every value of x that you put as the power of e, it won't change the fact that e to the power x plus 4 is positive.
What about the second ln?
The second ln, there I have to emphasize. So there we have to emphasize. So say, so because its power now is that, so we have to mention that this should be 2x like that.
Sir,
Hello.
on the part for ln 2x squared over x dx, I'm a bit behind. How did it come up? How did it? Okay, how was it ln 2x? Where did the power go?
When we are substituting, we don't carry the whole power sometimes. When using substitution, you may wish to carry just the, have you seen what happened on A? We did not say let u be 7 plus 6x squared to the power 9. We left 9. We just picked the inside of that to call it u. And after we called it u, when we took it back as u, we put back 9. So it doesn't mean that when we say let u be equal to ln 2x, we must carry the power 2. No. We can leave the power 2 there so that you can achieve what we want to achieve.
All right. And then there on the power 3.
So on the power 3 now, you're
Yeah.
integrating. You're integrating u squared du. So obviously to integrate, you add a 1 to the power and divide by what you get.
All right. Thank you.
So let's do another one. Now let's do k. Now let's do k. We have the integral of x squared multiplied by cos of x3 plus 2 minus x squared multiplied by e to the power x3 plus 2 dx. What if you had a 2x in the denominator? When there's a constant, it doesn't worry as much because you can easily introduce a constant. What we don't introduce is a variable. So for constants, don't worry, they always be introduced. So how do we face this question? So some of you may not it may not have proper knowledge on how to differentiate a function of this nature. How do I differentiate the cos of x3 plus 2? To differentiate cos, you use the quotient, you use the chain rule in this case. So you say, I would differentiate cos, it becomes negative sign. And then I write the angle as it is. When I'm done, I multiply the whole thing by the derivative of the angle. So I now differentiate the angle. I'll get 3x squared, which you can write as minus 3 sine in minus 3 x squared sine x3 plus 2. This was for cos. Okay. What happens if you differentiate sine x3 plus 2? If we are differentiating this, what do we get? Well, we're doing the same thing, but I now want us to start with by differentiating the angle. So get 3x squared. And then multiply by the whole thing. Derivative of sine now is cos. And then copy the angle as it is. If you look at this, this is what we have here. They are related. So we're thinking of how to do that thing there. How do we integrate the product of x squared cos x3 plus 2? So every time you are given to integrate, well, you are thinking of what could have been the question here. What was differentiated for us to have this thing? That is the question that you always ask yourself. So you say, this is equal to so we first for the first one, let u be equal to x3 plus 2. And then differentiate u. We're going to get 3x squared dx. And then let's solve for dx. So divide by 3x squared. We'll divide by 3x squared. So what we have now is dx is equal to du over 3x squared. Also here, let v be equal to x power 3 plus 2. Then differentiate v. You get 3x squared dx. So for dx, so we have dx is equal to dv over 3x squared. Then you get this now and say, so now I'm having the integral of x squared multiplied by the cos of u, everything multiplied by du over 3x squared, minus, so I'm expanding there and distribute the dx. So minus the integral again of x squared e to the power u. What is dx? I mean to the power of v. What is dx? I'm putting the v over 3x squared. So now this x squared and this x squared are cancelling. This x squared and this x squared are cancelling. So what do we get? We're getting 1 over 3 cos u du minus 1 over 3 e v dv. So we can easily integrate now. To integrate cos, we get sine. So we have sine u minus, to integrate e, we get e, and then plus c. Then we substitute. So what is our u? Our u is x3 plus 2 minus 1 over 3 e. What is our v? Is x3 plus 2 plus c. So this gives us the solution that we are looking for.
Excuse me, sir.
Hello.
Will you see the integral cos is this negative side?
Hello?
I'm saying the integral cos there, isn't it negative sign u?
The integral of cos is positive sine. The integral of sine is the one that is negative cos.
Oh, okay.
Yes. So I hope we don't have any other question.
Just have to sleep.
Can't get you. The 1 over 3 is coming from, have you seen this 3 that is there? Every time we differentiated solving for x, for dx, we had a 3 in the denominator. This is the 3 that we are taking out of the integral as 1 over 3. So 3 that was taken out of the integral as 1 over 3.
So,
No. Mhm.
I'm still finding it very hard, like to, how do you identify like which one should be your u, like let u be
The one that
like the
has
way
the
you,
higher power.
so it didn't, so even if the one that has a higher power is also a power, like the way v was.
Yes. What is guiding you is how do I differentiate? In this case, you're talking of the powers x3 plus 2. But how do we differentiate exponentials? We differentiate the power. So it's about the power. Then now you can compare. Do I have the power with a higher degree as compared to the coefficient of E? Yes, the power is 3, and yet the x that is multiplied by E is x to the power 2. Then you know I can use substitution here. Okay, so I would be encouraging you to attend all the classes because when we start the exam revisions, it's most likely you are going to only receive the videos if you attend the class. That's how the membership for YouTube is going to operate. Unless otherwise you communicate. So we are rejoining so that we can do by parts.